Okay, so today we will be drawing a cycloid. A cycloid is the locus, the position of a point on a wheel, while the wheel is moving in a direction. So in this case, the wheel will be moving clockwise, and since it will be moving clockwise, point P, apart from going around the circle, will be moving this way as well. If the wheel was stationary, just rotating on this point, on the same center, P would just form a circle with every rotation, with every turn. But since it will be moving this way without slipping, so if the wheel turns 1/5, it will move 1/5 of the circumference this way. It will produce a cycloid. So the first thing we have to do is to divide the circle into 12. So we'll use the set squares and divide the circle into 12 equal parts. And then we'll draw horizontal lines. So the next step is quite important. We have to put the circumference of the circle on a straight line. So we know where the circle started from, where the wheel started from, and where it's going to finish. Now we're going to do this geometrically, which means that we're going to measure 1/12 of the circle, and then on the center line, not at the bottom, on the center line, okay, we'll draw 12 parts. So that's 1, where we started from, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then there's another 1, because the wheel started from 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it has to go back to the starting position, 1. Now, what we have to do is, we'll measure the radius of the wheel, and then since it's turning clockwise, I'll go on point number 2 and rotate the compass not this way now, clockwise. So the first one was pointing downwards, the second one will be this way. Okay, this is number 2. So what I'll do is I'll measure the radius, put the compass on number 2, and draw an arc on the second line this way. Okay, if it was rotating the other way, anti-clockwise, I would draw the arc on this side instead. Okay, but it's rotating clockwise. So this is done. Now number 3 is this one. So I'll go on number 3 and draw an arc on the third line. And keep on rotating clockwise. So on number 4, number 5, number 6, 7 should be perfectly vertical because the 7th line is vertical. 8, 9, 10, 11, 12, and 1. Okay, so these are the points of the cycloid that we just located. And now we can join them either through freehand or through the use of French curves like these. It's really Up to you. The best idea is to try to get used to using freehand. Okay, so in this case, that's one part and the other half. Okay, so this black line is the locus of point P when it's doing one whole revolution in a clockwise direction. If it was going the other way around, it would form a sort of an arc in the opposite way. It would be like something of this sort. Okay, it depends on what you're trying to do, but obviously the length that the wheel travels depends on the size of the wheel. So we always divide the circle into 12. We always measure 1/12 of the circle and draw 12 arcs. So if this circle is bigger, this would be bigger. If the circle is smaller, the circumference would be smaller, obviously. So that's important. We always draw horizontal lines, we always measure the radius, and we always draw arcs from the center. Now, which direction we draw the arcs depends on the direction of the rotation, and where we start from depends where we're asked to start the cycloid. If P started from here, I would get this part starting from here instead of the center, and then it would start this one and you. Okay, thank you very much. This is a cycloid. If you have a question, just post.